cloud. Great.
Very good. Welcome to the December 19th, 2023 session of, I'm going to call it Clementine SDR and Ham-Sci technical session. My name is Dave, KV0S, and this week I was working on organizing. I'm actually setting up a VHF K9Q radio. So I got some questions for Phil when we get around. Want to try listening to 2 meters and maybe 440 or 433. And so that's the main thing that I've been working on this week. So next on the list, we have Nathaniel, W2 NAF. Go ahead.
Thanks, Dave. So I've been gone for the past 2 weeks, as people know. It's been quite busy. 2 weeks ago, I was in Boulder, Colorado for the CDR Science Steering Committee meeting. And last week, I was at the American Geophysical Union meeting in San Francisco. And both meetings went very well. We had good representation from Ham-Sci at the Fall AGU meeting last week. I gave 2 talks. I had a number of students there. Bill Engelke was there, and Rob Robinette was there as well. And Rob Robinette and Bill Engelke both gave posters. And one of the real highlights of the week was when Rob Robinette took us on a tour up to KPH. So he rented a van for us, and we had a few students and a few other professor type people. And we rode about an hour north of San Francisco and got to see both the transmitter and the receive site for KPH. We got a really nice tour. We saw where Rob has his stack of Kiwi SDRs and RX888s, and it was fantastic. So I got a lot of good photos of all of that. The AG was the NSF program officer has accepted our report for the annual report for the DAISY grant. So we have another year to keep working on it. I know Rob Robinette and Bill Engelke had some good discussions about where things are going to go with adapting K9Q radio towards working with some of the personal space weather station goals. Also, there were a number of announcements this week for awards and things like that. So one award, I'd like to congratulate Jonathan Rizzo, who was announced Ham of the Year for our Murgas Amateur Radio Club. So a big congratulations for that. And I know a lot of that is because of his efforts for the personal space weather station and specifically his VLF efforts. So really, really great. I wish I could have been there for the dinner for that, but that was like my one night when I just got home from Colorado, so I just couldn't. Let's see. Other than that, some other big news. Phil Erickson was promoted to director of the MIT Haystack Observatory this week, so that's really big too. I think that's it for now. The semester's ending for me. I'm going on vacation on Wednesday and Thursday, and I got my grades all submitted today, so I'm super thankful for that. So tomorrow I cannot tell you how glad I am that I have my grades in. That's a big relief.
Yes.
So, all right, back to Nat.
Oh, okay. Well, sounds like a good week, and I'd love to hear more of your trip to KPH at some point. So
Great.
we did hear from Rob last week, and he was coming back from the AGU meeting and talked to us in his car while he was driving home. So next on the list is Mike, AAK. Comments?
Oh, thanks very much. Greetings to everyone listening. Back to you, Dave.
Okay. Next on the list is Bob, N5BRG. Go ahead, Bob.
Well, hello, everybody. I wanted to check in here tonight and hear these stories that Nathaniel's telling pretty interesting. I hope all of his students are happy with the grades that he got posted. Anyway, sounds great. And back to you, Dave.
Oh, okay. Next on the list is David in 1HAC. Go ahead, David.
Good evening, everyone. A number of interests have come up. One thing I've been realizing, I get WWVH and WWV very commonly on the same frequency, and thinking about how do we discriminate those two. And we may want to put a little effort into doing that. I get 5, 10, 15 megahertz quite often, both of them coming in. The other thing that is an interest is that someone reported on, let's see, what's that? It was the SEQP meeting. They had been getting long delayed echoes on the 10 meter contest last weekend, a week ago, and on the order of 2 seconds or so. And that's a personal interest of mine, that very interesting, thinking about how to detect them, especially in an automated way. I mean, there's lots of anecdotal evidence as hams having heard them. You hear your call sign coming back. It's like, wait a minute, I'm not transmitting. But being able to take whatever signals we have going out and kind of searching for instances of them coming back at anomalous delays. This is not going once around the Earth, or even, a few times. This is going way out and coming back. 2 seconds is, halfway to the moon and back. Anyway, and very good to hear about Phil. I thought he was already pretty well placed, but I guess he's even higher now. Good for him. I guess that's about it from here, except that we're trying to stay dry. We've got some record flooding going on in certain places around New Hampshire. So that's life, climate change and all that. So back to Nat.
Okay. Next on the list is David, KD0EAG. Go ahead, David.
Hello. Nothing really exciting to report. So I think I'll just pass it back to you all.
Okay.
Thank you.
Okay. Next on the list is Franco, K4VZ. Go ahead, Franco.
Hey, good evening, everyone. Congratulations to John for the Ham Radio of the Year first. It's well deserved. No, and a few things I have. The first one is that after Dave and Glenn Elmore, they mentioned something about the dual receiver ADC. I would like to present something that Phil Harman, VK6PH, has been working for the last few months, I should say, and I've been helping with. And maybe in the second part of the discussion, I can show you a little schematic, a little feature, and we can discuss it together if you like. A couple more things is regarding that VHF things. I gave Phil Karn, if you remember, a few days ago, the fact that I created a branch for RX888 that can now use the should be able, I should say, to use the VHF tuner. So with that branch, maybe I can use the link. You should be able to work on VHF 2 meters and 70 centimeters and so on. I haven't been tested, I haven't tried anything, but you're welcome to be the guinea pig for anyone who wants.
Very good.
Third thing is, as Nathaniel mentioned, I've been working with Rob Robinet and Bill Engelke to get the data from KFS into a format that is compatible with the GRAPE format. One thing we found out, and I'm glad that Tom and 5G is here, because we found out that it does a decimation by 800. So I was sending the data at 16 kilo sample per second, but we realized that Bill expected data at 10 sample per second. So there's going to be some discussion there, maybe again in the second part of the call about that. Back to Nat.
Okay. Next on the list is JWB8 SBI. Go ahead, Jay.
Well, good evening, everybody. Not a whole lot new ham radio wise here. I understand that there's some massive solar flares have hit the Earth, so HF is pretty much QRT at the moment. That's what I understand. I'm QRT on HF for a while. My antenna, it's a more fine junk antenna. Do I really have to say more? So that's about all that's new here, ham radio wise. Happy holidays to all. Stay safe. Take care, and see you all later on down the log in January.
Yes. Okay. And next on the list is Jonathan, KC3 EEY. And congratulations, Jonathan.
Hi, everybody. Thank you, and thank you all for your kind words. I do not feel that I deserve it, but I am very thankful and very shocked that I did receive it. And I was happy that I was able to motivate everybody enough that they felt that I was worthy. Hopefully with my passion for VLF, I could really really make a positive difference in the field. But thank you all. I've been pretty busy myself. If you notice on the Hamsci list, there was a really nice solar flare that occurred on the 15th, and one of the things that I really was really nice about this was that it was that it had such a intense effect. Actually, it was probably the biggest solar flare of the solar cycle, and there was also a solar flare that occurred a couple hours before it that had an inverse effect on NAA. I could show you quick the so what you're seeing here, this is the amplitude carrier phase and modulation phase plot of NAA. On December 14th, you can see at around 1700, there was a big X-class flare here, and what was interesting about it was the decay time, which is typically these a lot of solar flares have a fairly short decay time, but this one kind of hung on a little longer due to the extra ionization. And the solar flare around 1400 UTC, you could see that the amplitude actually went all the way down, and that can occur in certain circumstances, depending on where the which part of the ionosphere that the solar flare hits, where on the Great Circle path from the transmitter and the receiving antenna, and sometimes you could get a reverse effect. So this is actually a really nice really nice response. And what was somewhat surprising was that you can see this response really nicely in the spherics. So this is a compressed spectrogram of that day. You can see the first feature from 3 to 3:30 in the morning, UTC. That is a local power outage, and I know that because you could see these bands of noise around 3 kilohertz, around 3.2, 3.3K. And those bands of noise are they come from loads on the mains. And I know that because for that small period, that band is gone. So this noise that you see, this noise band around 3K, that is local mains interference. Could be from a switching power supply, probably from a switching power supply, something that's on all day. The other feature that you see is around 1700, you can see in the spherics that the spheric band was actually attenuated during that time. So you can see the purple here, and it actually extends past 7 kilohertz. So it's about a 1300, 1500 kilohertz region where the solar flare actually diminished propagation for spherics, which was really, really, really interesting. Something that I did not that I don't see very often. And with this compressed spectrogram plot, you could very easily tell. The vertical lines you could see during the day are daytime mains harmonics. They seem to have increased lately, and I'm not sure why. I'm gonna have to check the ground eventually. But I thought this was a really interesting effect, and I wrote up a little blurb on the list. Lastly, I've been contacted about my my activities. There was a former Case Western student that contacted Christina regarding observation of whistlers and dawn chorus. So she contacted me. And there was also some contacts from AGU. And again, Nathaniel, thank you for passing those along to me. That's all I have. Back to the net.
Okay. Next on the list, we have Michael Howen, AC0G. Go ahead, Michael.
Hey, everybody. Been only marginally active this week. Trying to reconfigure some wiring and some antennas and preamps, but otherwise keeping a couple of RX 888s up running on monitoring with Whisper Daemon and Raspberry Pi 5 to see if I can't get the K9Q web version going. I'm not sure whether it'll work on a Raspberry Pi 5, but I'm going to give it a try. That's it. Back to.
Okay. Next on the list is Rob Robinette. I don't know if he's ready. He looks like he's typing. He's got his finger up. Well,
There, now you should be able to hear me.
yes, we can hear you.
What a mess this sound world is on computers. Okay, well, yeah, I've been, as usual, busy. Of course, AGU consumed a lot of last week. Over the weekend, I've been promising Franco that I would do this modification of the WD record so we generate the right sized WAV files. I haven't gotten to it. It is nearing the top of my list. I think there's some issues there that we'll talk about offline. But one thing I did is I did port Whisper Daemon onto the onto the Pi 5.
Oh,
There's an RX 888 attached to a Pi 5 in Austria, and Phil and I got that up and running. I have to say I'm a little disappointed in the performance of the Pi 5. It's it's useful as a host for a 888 in RX and build software, but it really isn't capable of doing any more than that. So I'm you can't run you can't run the Whisper Daemon at the same time as you're decoding, unlike the Orange Pi 5 where you can. So I at this point would have to say I wouldn't see it as being terribly useful for our applications or my applications. So that's the biggest deal here. I also we're expanding the number of sites that are recording Doppler shift and spectral spreading. As I deploy this new version of Whisper Daemon out to sites, the Whisper Daemon sites. One thing we need to validate the spreading numbers. I'm not entirely confident. So one of my tasks is to set up a test environment to test the Whisper Daemon and the spreading numbers. So I did see an incredible presentation this morning from Wynn, looking at the Doppler shift results from the eclipse. And he went one layer deeper and started to look at the meters per second measurements that we get by looking at different bands simultaneously. And there's it looks like the technique, the spectral spreading techniques, gives a much less noisy and accurate and a more accurate level, F layer level, than you get from the Ionoson data. It's really his comparison of the two was quite impressive. And there's another subject maybe we can get to later that has to do with 100 millihertz offset in the GRAPE WWV data. So I have a number of topics to talk about later. Back to Nat.
so, Rob, very quickly, is that talk available online anywhere?
He's going to put it up, I think, as one of his Eclipse reports. It'll be up on the whisperdemon.org site. I think he wanted to do a little more validation of his calculations. He was to make sure that his mathematics was all correct. The math, he was a little, he had to make path-like computations with sines and cosines and square roots in it. And he wanted to be sure that he had that all right. But it should be up soon.
Okay, thank you. Next on the list is Phil Karn, K9Q. Go ahead, Phil.
Hi, guys. Not much to report here. Didn't really do much over the weekend. Had friends in town. Yeah, really not sure what to report here. I'm still catching up on all my mail over the weekend. I think Rob is overstating the problems with the Pi 5. I mean, you got something like a third to a half of the machines still left, and the real problem is simply that the programs that demodulate Whisper D are just too CPU intensive. I point out that there has no problem whatsoever in running FT8 skimmers in all bands at the same time, because FT8 uses a more efficient, more newer coding scheme called
low density parity check. So anyway, no, actually, I'm personally rather happy with the performance of the Pi 5. It means I can finally have a machine that is dedicated to K9Q radio and it's real time processing without having to have cycles stolen away by stuff that runs in the background. That doesn't have to be real time. So I've got one here. I haven't brought up KNIQ radio on it yet, but I have been running it and I'm doing other things on it. The main reason I haven't is because I don't yet have a case for it. All I have is a couple of surplus heat sinks stuck onto it, and I'm kind of afraid to load it up with something that when I don't have cooling. Anyway, that's about it. Back to you guys.
Okay. Next on the list is Tom in 5EG. Go ahead, Tom.
Oh, good evening, Dave, everyone in the group. Last couple of weeks have been concert season, so I've been doing audio for a bunch of different concerts in the area. I've started taking a look at Whisper Demon, and Rob, I have a couple of questions. Would you have a few minutes during the general discussion to just give me a couple of basics here?
Sure, of course.
Okay, so we'll go back to the group and pick that up when we're ready, Dave.
Okay. And no other comments from you?
No.
In general? Okay, that brings us, I think, to the end of the list. Did anybody get missed? Well, then we're open for general discussion.
I just wanted to pipe up. I meant to mention the solar flare, and it actually got mentioned on National Public Radio. But they, whoever they were interviewing, I can't remember. It was a woman who was astrophysicist, but they were talking about it having affected Central and South America, as if we didn't notice it here. And I actually had noticed that WWV disappeared for the most part during that flare. It was apparently the largest flare yet in this solar cycle. And we'll get more when that, probably when that region comes back around. It's behind the sun now. But that was an interesting one. Yeah, we don't usually see the effects on this side, just the way things time out. But this one, we certainly got the full effect of it. I wonder if anyone else had, and I'm sure it'll show up in the GRAPE data. Back to net.
Okay. And so we're open for general discussion.
Yeah, Rob, I have a couple of quick questions about Whisper Demon.
Yes.
When you receive the Whisper data from KA9Q, does that come in as a bunch of different IQ audio channels for the different bands, or how does that come into Whisper Demon?
Okay. No, what Whisper Demon runs, listens to the PCM, 16-bit PCM streams coming out of K9Q radio and records those into wave files, 12 kilohertz kilosample wave files, and then hands that off to the binary, actually the Whisper Demon binary that's extracted from the JTX distribution. So the way it replicates exactly the way WSJTX does the processing of the wave files that are generated inside WSJTX.
Okay, so for example, to get multiple different bands on Phil's software, you implement multiple demodulators and you get multiple 12K IQ streams. How does Whisper Demon, does it know about the structure and the SSRCs and all of that? Or does it have a different IP?
Yes, there's that K9Q runs entirely independently of Whisper Demon. So
right, each one has its own directory too.
It has its own directory tree and so on. So Whisper Demon listens on a multicast, RTP multicast stream generated by K9Q radio. Okay. And that that stream has many bands of samples in it as you configure 9Q to do. So that's the oh, I see why you can't see me here. That's I'm having
There you are.
there you are. Yeah, it was somehow I'm in IT purgatory here. So I'm
Okay.
having to use my laptop to talk
Well,
to you guys right now.
we can
So
see
you're
the
seeing the side of my head over here.
yes.
I'll leave this over here. There's no reason for me to be on twice. So the so yeah, the RTP stream it multiplexes all of the the bands that are configured for PCM for Whisper. So
Okay.
they're on one multicast out packet stream, and the
Yeah.
RTP packets are embedded in segments of each of the incoming packets. So there's
Okay.
a utility program that is derived from Phil's PCM record, Clint K9 K7 OEI modified it, and I did some further modifications, and I needed to do still further modifications on it for Phil. But that WD record utility is part of the K9Q package, so you will find it in K9Q directory. And it is executed. The binary WD record is executed by Whisper Daemon, and it records a wave file for each of the bands that you've configured Whisper Daemon. So there needs to be coordination between the two programs. K9Q needs to be configured to listen on all the bands that you want to listen on, and of course, Whisper Daemon needs to be configured to listen, record wave files from those, and then execute the Whisper D decoder at the end of each 2-minute cycle.
Okay. I was looking on the configuration file for Whisper Daemon.
Yes.
And is there an example of one in the receivers list? I couldn't find a KA9Q description.
Yeah, probably you need to check out go to the Whisper Daemon directory and execute git checkout 3.1.0.
Okay, I'll do that then.
Okay, and then you will get that. That is the branch that supports K9Q.
Okay,
And there's
so
and there's a template, a configuration template file that includes, I hope, enough explanation of how to configure a K9Q to work in that. So, but you have to be on that branch, and I'm
okay,
trying
very
to
good.
I'm trying to check it in and make it into the main branch, but then I get off onto Raspberry Pi configurations and supporting Franco and all the things that I want to do rather than learn how to do GitHubbing.
Okay, all right, very good. I didn't realize there were branches other than master on there. I'll go take a look and snoop
Yeah.
around. All right, I
Yeah.
think those answers the questions.
Okay, it's
Thank you.
Phil is commenting. Let's see. Let's see what he's.
That is Cousin Euler formula.
He gave
I'm
the
just
formula.
describing Euro's formula in response to Jay's question.
Okay.
Yeah, I'm just looking behind Phil's picture.
Yeah, that I took that picture in Paris in 2015. You can see under pi it says Sal Pi. It's
Oh yeah.
they were science one of their main science and technology museums in Paris. So I mean, of course the room is round inside and it's got pi to like the first 1,000 digits or so written on the walls. But I like that formula because anybody who's done digital signal processing knows, or any kind of signal processing, it's a really important formula.
Been called the most beautiful formula.
It is.
Because it's got.
Although I look at it and see something very simplistic because it's just it's a simplification of a much more general formula.
Well, it's elegant.
Very elegant, yes.
Dave, if we have time, I would like to show the stuff from Phil Harman to the whole group.
Yeah.
Since there was some interesting. So let me share here my my thing here, and tell me if you can see it. Where is the share here? Share. Do you see the my screen, Dave?
Yes.
Okay, so basically, this what I like to talk is something that was an interest that was partly by some comments of from David McGaw last week, and partly from some other comment that Glenn Elmore and 6GN made at the TAPOR, and part from some work that Phil Harman, VK 6PAs, and I've been doing in the last 3 or 4 months. Also, David Witten has been helpful in the conversation, and basically Phil came up with a device, I would call it an idea, called the DFC SDR, and the next slide I'm going to show you an architectural block which has basically a dual current 16-bit 130, the usual LTC 2208. And also, we thought it would be useful to have a way to do some transmission, because after the success of Whisper Sound, we think be able to transmit on different channels at the same time is something that can be really useful. And for this, we have a DAC that can that. And then to take advantage of the Cypress FX3 capability with USB, it would be the connection to the host. The idea again is not to use any FPGA, just use FX3 transfer samples in and out, and similar to what we do with K9Q radio, and where the host does all the computation. The clock will be a master clock at 192.6 megahertz. Optional an external clock. It will also allow for GPIO pins for shift register, because the Anon high pass filter, low pass filters, and power amplifier, they're all connected with shift register, so you'll be allowed to add filters and so on. And in order to take advantage fully of the FX3, which I think can do up to 400,000 kilobytes per second or something like that, 425, I think, we would design 3 configuration. One would be a so-called, I call mode A, B, and C, by an ADC that can run at the full clock frequency, and the samples could be either full samples, or every other samples could be sent to the host. The other option would be to run the 2 full ADCs in sync, coherent at half the frequency, or even, and I'll tell you why in a second, to be able to run one ADC and the DAC at the same time, because in full duplex mode, which I think is possible with FX3 firmware to realize, we will be able to use Warren Pratt pure signal algorithm to basically get a very clean signal on the output from the transmitter, from the AC. And the DAC, again, with the same approach, could be also used for transmission of Whisper, and similar to what Whisper Sound does, but on multiple channels. And our plan, field plan, and my plan, of course, is to keep the schematic, the software, all open source. And right now we are at the design and architecture review phase, and that's why I would like to share with the rest of the group, because there could be some ideas that we haven't thought of, or some comments. I'm sorry, I switched on the wrong file that we haven't thought of, that could be useful for the whole group. And then eventually we're gonna do cost. I'm gonna start to work on the firmware for the FX3, since there is no FPGA. And eventually we plan to start doing some kind of prototyping or something like that together for that. And without further ado, let me just also show you. Can you see the block diagram from Phil Harman?
Just the top. There now, the
Huh?
full screen. Now
The
you
full
can
screen.
see the full screen.
Okay, perfect. Okay. So again, the heart of the device is the FX3, and then the idea would be to use the so-called data bus to connect to the 1ADC, and then with a switch here, be able to switch between 2 ADC, working in sync, or one ADC and the DAC, and we would use the address bus to connect to the DAC at the same time that the data bus connects from the ADC. There will be, here the clock here, which could be either the, standard internal 129.6 megahertz clock, or an external clock like a GPSTO or something like that, that would run, 400 kilohertz and then eventually multiply by 324, go out at the same frequency. We also had provision these GPIOs for external devices like the ANAN boards, LPF, HPF, or power amplifier, some debugging via a UART devices and controller devices via the I2 channel. So we basically will be able to take, of course, a couple of LEDs for diagnostics here and the power and things like that. But we'll be able to take full advantage of what FX3 can do. I mean, I think now the RX888 takes advantage of probably half of the capability of the FX3. There is a lot more that can be used, and it will be a device that I think will be very interesting for a lot of application, because if you think about being able to have two receivers at the same time, I think it's something that coherent, is something that a lot of people can relate to. I'm interested. Of course, all the controls as usual. So this will be, an idea that Phil and I and Dave, of course, are working on, and anyone who's welcome to comment, and take part of it. We want to keep it open source and see what can be done with it.
Yeah,
So
just in case
that's,
it's not clear, KNIQ radio uses what Phil is calling direct Fourier conversion. Same thing.
Yeah, it's the same thing.
Franco, I got a quick question for you. The 129.6 megahertz PCXO, where are you getting that frequency from?
Oh, the reason for that frequency, at least in KNQ radio, and I wish Phil Harman was here, but in KNQ radio is a nice frequency, because if you do the math, it turns out that the Fourier transform for that with a 20 milliseconds period is a very nice, with very small factor. So it's very easy to compute the FFT of that. Some other kind of rough, but again, this I like your comment, because we are just starting to decide. So if you think there is a better option, definitely it's
No, the reason I ask is because I'm using that frequency, but for a different reason. It's a fractional harmonic of 28.8 megahertz.
Well, it's for both reasons. It has a reasonably small set of prime factors for my FFT, and it's reasonably clean for the synthesizer to generate.
Yeah, I use it because the RTLX SDR has 28.8 in it, and I'm feeding that to an up converter that's I think it's 4.5 times 28.8. So it's a clean fractional harmonic. But yeah, interesting that comes up again.
It's clean, at least when the frequency you want is 27 megahertz, which I kind of like, because if it gets out, who cares? Right?
Yeah.
and it's
the
stored
other
after
thing I
limit.
wondered, I didn't check the data sheet, but does the 2208 have tri-state?
It has differential or single-ended.
Differential, yeah.
Yeah, I don't
No,
think
but
it
I'm
has
wondering,
tri-state.
does it have a tri-state ability?
I don't
No,
think
I don't
so.
think
Who
so.
uses,
Because I'm a little. You
who
may be
uses
able to
tri-state
avoid
anymore?
using the buffer.
Who uses
I
tri-state
see.
anymore at high speed?
I use
I don't know. I have
tri-state
to
all the
look in
time
the.
for multiplexing.
At high speed?
Well, you turn it on, you turn it off. I mean, you either have it enabled or not, but
Yeah.
it doesn't matter if the DAC gets fed all the time.
Yeah, but I mean, these lines are transmission lines, right? So
Oh, I know. I'm well
yeah.
aware of that.
Okay.
But
Yeah.
well, yeah. I'm just wondering, is the delay of the buffer going to be a problem?
I see. The one thing, David, that we are looking at is to figure out, and again, without the prototype, it's going to be a wild guess, in my opinion, the delay between the ADC, coming in and going into the computer and going back to the DAC, because for pure signal, Phil told me that has to be Phil Harmon. I mean, has to be very quote consistent. He says it doesn't really matter how much. I mean, as long as it's reasonable, it has to be consistent. I don't know how the USB bus is able to keep it consistent, especially because you're dealing with the OS scheduler and whatnot. So that's going to be another big question that I don't know. The FX3 is very simple in size, so I'm pretty sure that the delay on the FX3 should be very controllable, on the GPIF I/O system. But going to the host is going to be a wild guess, I guess. I don't know.
I don't know USB like you do, Franco. Is this using the synchronous mode in USB?
So USB, I use bulk mode because according to all the documentation I've seen, Phil, bulk mode is the one allows you to get the most bandwidth. ISO synchronous is less efficient, I think. I don't know why, but that's what all the numbers I've seen from the documentation from
Okay,
Cypress
well,
show that.
as long as it works.
Yeah. And that's
So
what
you
they
have
use
to
for all
try
the
both.
storage. For the big disk and so on, they all use bulk mode. So it's kind of becoming the standard for this kind of throughput.
Well, discs aren't synchronous. I mean, I don't know what digital video would use.
Yeah, I don't know. That could be a question.
Yeah, I'm interesting that we're talking about synchronous data at these rates, because when USB first came out, we were having trouble getting audio to pass through properly.
Yeah, right.
Which version of USB was that?
Wait, 1.0.
Well, I certainly, but one. Two, did they already put the isochronous mode in it?
Well, it got faster.
Yeah,
Yes,
it certainly got
yeah.
faster, but still, a lot of times
And
you have to put a sample rate converter in the way because your clocks are all different.
Yeah,
and
the
not
funny
two at
thing is,
full.
I was going to say, the funny thing about communication, digital communications over my career is that there's a lot of research that's gone into, fairness and scheduling and all these things with data communications. But in the real world, people just make it faster. You don't have to worry about it. That's what's happened.
Yeah,
Yeah.
but digital
right?
people don't understand sample rate differences, and you get pops
Well,
and clicks because you're
that's a
doubling
separate
samples
problem.
or dropping samples.
Well, I mean, if you're talking about skew between sources and sinks, that's a separate problem. But I'm talking about how when Ethernet came out, it was a cottage industry for a while to study CSMA CD, right?
Yeah.
And how efficient is it? And does it scale? And can it, all this kind of stuff. And what do we actually do in reality? We just crank clock speed up factor of 10 and then another factor of 10, so we didn't have to worry about it. And then another factor of 10. We don't even use CSMA CD anymore.
I have the
In
feeling
fact, you
that
can't.
after 1 gig or 2.5 gig, the Ethernet is, I mean, I never seen much of a 10 gig Ethernet available to to people like us. I don't know.
Yeah, that's been a disappointment. Gig Ethernet came up fairly fast, but 10 has been
Yeah.
around, industrially for a long time, but has never made it into the home. And it's not like there isn't a use for it because hard drives have been faster than a gigabit for some time now. It's not
10,
Yeah.
10 gig
use it. Yeah.
is really quite available in home market server board or
Oh, is it?
PCIe
Well, I've been
boards
looking for
for
one. I've been
computers.
looking for one, but it really is cutting down my choices. And you don't see it on a Raspberry Pi, for example.
No,
And
you
it's
don't
quite
see
a bit
them
more
on Pi,
expensive.
but you can get a PCIe card with the interfaces on. And of course, home switches are now fairly readily available with 10 gig.
Yeah, they're a lot more expensive.
Not really. If you
10
try to
gig?
use if you try to use RJ45 connectors and twisted pair cabling, they're more expensive. But if you use SFPs, they're not more
Right.
expensive.
I was going to point that out because I don't understand why we still stick with copper. I mean, you look at the enormous signal processing required to cram all those bits in the copper when the easy to do is just use fiber.
Yeah, well, a fiber or what's called direct attached copper, which is just a 10 gig signal, raw signal right on a differential pair. The key thing is the power and the latency of the RJ45 interface is really considerable. It burns a lot
Yeah.
of power to put it on copper, and it adds a lot of latency to it as well. If you look at the pricing, an SFP plus interface at 10 gig is really not that expensive. You can find DAC cables in the $10 to $15 price range. You can find fiber plugs in the $20 price range. So it's really not that expensive.
What color cable do I need for it?
Typically, it depends on the distance you want to go, but OM3 or OM4 fiber is generally good
But
enough.
not OM what? So not orange. I want teal or whatever.
Yeah,
Yellow.
for most 10 gig will run even on orange fiber for reasonable distances.
Okay.
If you're in the 100-meter range, I think the orange fiber, my recollection is, works fine.
Okay. Well, it would work well in my house. I've got orange fiber in my house, but I'm only running it at a gigabit right now. I mean, the reason I'm doing that is to try to cut as many sources of RFI as possible.
Mm-hmm.
We ought to
Yeah,
have
so-
Glenn Elmore on here give a talk
Yeah.
on RFI. He seems to really know this.
Yeah, I was on that committee for about 8 years.
Well, he said something. I'd probably have already said this, but he said something to me some months ago that at least at low frequencies, the only thing that radiation is just not an issue because everything is too small to be an efficient radiator. It's all about ground loops. And as soon as he said that, I knew instantly he was right. But
Yeah,
knowing that and fixing it are two different problems.
right. Of course, Ethernet, of course, doesn't suffer from ground loops since it's all transformer isolated.
Until you go to Cat 7, and now they run the shields end to end.
Well, yeah, they do run. You can have shield loops, but the signals are differential and transformer
Yes.
isolated.
But
Yeah.
but the common mode rejection on those little transformers is rather poor that they use in those.
Oh,
And so you can absolutely see common mode RFI coming in through an Ethernet cable. So it's we're seeing those at on Kiwis, and the quick solution is to change the Kiwi to run a 10 base T instead of 100 base T mode. That
okay. I was going to say, speaking of Kiwis and Ethernet noise, I just found a very large source of Ethernet noise getting into my Kiwi, and it wasn't the Kiwi's own interface. It was my Time Machine's NTP server, which happens to share the same 5-volt power supply as the Kiwi.
Oh, well, that's yeah.
Yeah.
Okay. Yeah.
So
Yeah, that's always it. Yeah. The
that
ground,
was
power supplies are the power supply ground is the source of all RFI evil.
oh
and
God,
as they say.
I'm just now discovering. I wish somebody had told me that a long time ago.
Right. So I think that there really needs to be a whole new class of power supplies that are kind of that address this ground loop problem that we really
Yes.
need, and
Yes.
and the idea of just putting in some toroids on the lines is a band-aid.
Interestingly enough, just having a pile of wall warts plugged into an outlet strip does give you galvanic isolation, right?
It's better than having them share this, take the DC output and put a splitter on it. It's better, but there's still problems with that solution. It's
Well,
not
yeah, of course. But I'll probably go back into my pile of old analog 5-volt supplies, and that will probably fix the problems I'm gonna have.
Yeah, that's well.
I knew there was a reason I kept those around.
So I found anecdotally that the gigabit Ethernets are quite a bit quieter than the 100 meg Ethernets.
Really?
Yes.
Yeah.
They have the same clock rate, 125 megahertz.
Well, the signaling is a bit different, and on gigabit they're running 250 megs full duplex on all 4 pairs, and the coding is such that it's quite a bit quieter They
Five
tend to have
level
less
coding.
discrete spectral lines.
Well, I think the difference there, I looked at this, and the difference is that the length of the scramblers. Ethernet, 1 gig Ethernet uses a scrambler that's like 1 billion bits long or something like that. While I think that 60 something kilohertz line that we often see, I think that's the repetition interval of the scrambler and when it scrambles an idle sequence. That's where that comes from. 61 or 63 kilohertz. Those lines
You'll see a pair of lines on 100 base T. A
Yeah.
pair of lines
Yeah,
that
a
are
pair,
around
right.
64 kilohertz multiples above 14
Right.
megahertz.
And that's coming from the scrambler operating on an idle sequence.
Yeah,
Yes.
well,
Those you know,
yeah.
the pairs are always active. That's how the link light stays on.
Yeah. So the 1 gigs are in all the testing I've done, they're quite a bit quieter.
Yeah,
Yeah,
but Kiwi doesn't have a gigabit Ethernet interface on it, and so
right.
that and a
But
bunch
you
of
can drop it to 10, but then you're probably going to get a very large amount of 10 megahertz. Well, hey, I've already got
no, it works
already
well. No,
got huge amounts.
I run them at 10 at most sites whenever I can. I run them at
Yeah.
10. The only problem you get there is that if you get a dumb switch and you run K9Q radio.
Yeah. I know.
So
It's the other guy's fault.
So the
Is USB 3 noisy too?
I don't see any. I haven't seen any noticeable noise from the on the 888 that I can
good.
associate with the USB 3 interface. But you know, we're still learning about how to use the 888. I've been experimenting at KPH. When we went out on Wednesday, I installed the second 888 out there and a Ryzen 5 server to attach it to. So it has a lot more CPU cycles. And I've been able to compare the two. And I put an extra 10 dB of LNA ahead of this new 888. And it does help out there. I do get a few, maybe 1 or 2% more spots from the with the additional gain.
I meant
So
to ask you, Rob, what's the gain of that amplifier?
it's about 12 dB. The
Okay.
external amplifier.
Yeah.
Yeah, the external amplifier added was custom built for me by Clint, K70EI. And it's about 12. He said, I didn't measure it. He said, but I absolutely believe him. It's 12 dB.
Okay.
And it's it interestingly it does that is too much gain out there at KPH. So I actually had to turn down the VGA gain from plus 20 to plus 15 to avoid overloads of
Okay.
so
Yeah, so you're getting about 6-7 dB gain effective.
yeah, I needed an extra 6 or 7 dB out there to fully for full levels of sensitivity out of KPH.
Yeah, and that's enough to override the input noise of the RX-888 amplifier.
Well, there's additional gain ahead of between the TCI 530 antenna and the original 888. There's about 10 dB of gain there, and that's clearly not enough. It needs more like 15 dB of gain.
Yeah, but you're finding that the amplifier in the RX-888 is noisier at that gain than using the external one.
Well, it is at low gain, certainly.
Yeah, right. It's apparently, according to Clint's measurements, that variable gain amplifier in the 888's optimum signal noise occurs at about plus 20 dB gain. So
actually, its minimum noise figure is at full gain, but that's too much.
But yeah, that doesn't.
So it's actually noisier, effectively at low gain.
It's
noisy. Very much so.
That's annoying.
Well, I mean, I can go back and crank up the gain on the original one and go from 20 to 25, and see if the internal, whether that external LNA really was necessary, whether KPH, the system works just as well with an extra set to plus 25. That's an experiment that I can do very easily. There's a good Grafana page that allows me to compare the two sites into using the WSPR spot counts and differences between the two spot reports. I can see in some depth the difference in performance between any two receive sites, but those are the two that I'm examining right now that are under test.
It's
So
in here somewhere.
I'm sorry?
It's in here somewhere. Signal noise figure versus gain. I know it's in here somewhere. It's very
Well,
straight
it's
down
not
the-
on that. It's the input amplifier. You're on the ADC.
Well, but it's oh, I'm sorry. You're right. You're right. That's why I'm not finding it. Never mind.
Too many parts.
What was it? Yeah, too many parts. Which ones do you have me remove, sire? That was Amadeus, in case you didn't catch the reference. What was the number of the amplifier?
Is an AD part. I forgot. Let me look in the code.
Okay, while you guys are poking around, I can share you a comparison of the
Yeah, Tom,
let's see.
100 meters is good enough for my house.
By the way, Phil, there's a present for you in the mail today
Okay.
to address your RFI, common mode RFI problems.
Okay.
Handcrafted. Anyway, this is the two RX-888s at KPH. The green one is the standard one set to plus 20 dB of gain, and the yellow trace is the 888 with 15 dB of gain or 12 dB of gain, and the ahead of it external gain, and the VGA turned down to plus 15. So you can see, if you look at these down here, you can see that there's you're looking at 15 spots being decoded, by the external gain one. So 9, 7, 8 extra spots out of, that's out of, what is it? It's 200 spots, so 4% more spots. So what I'll do is I'll go in and change the gain on the green one and up it from 20 to 25 and see if it matches, in which case we don't need the external LNA is not needed. Anyway, that's one of my experiments that's running right now.
I found the proper spec sheet for the 8370, which is a VGA. If I can grab the screen here. Let's see. Here we go. Yeah. So unfortunately, they have this thing called a gain code rather than just decibels, but you can see how here, figure 6. First of all, low gain mode is terrible. Obviously, that's there just if you're dealing with very strong signals and you need a high IP3. So you can see it flattens out. It's a monotonically decreasing curve, but up here is just too much gain. So, but it flattens out, pretty quickly down here. And I think this is in the vicinity of about, how many dB was that? I implemented this in software.
Would 20 dB be 100? Or
no, that's a code. A code is an arbitrary units that you program with. But you can see that it flattens out.
Yeah.
It doesn't rise again. So you want it as high as you can without overdriving the amplifier if what you're trying to get is minimum.
Also, what's interesting is how much noisier it is in low gain mode.
What's that?
The noise figure is very much worse in
Oh, yeah,
low-gain
yeah,
mode.
that's what I
doesn't-
said. I think it's
Weird.
only there if you really need, you're doing strong signals, you really need a high intercept point. So yeah, you don't use low gain. I don't use low gain mode at all. I mean, I support it, but I never use it. Once I saw this graph, I never used it. Actually, I'll put IP3.
That was
It's output. Okay.
Dave
Yeah.
Whitten is implementing this. There's no input amplifier, right, Dave? We're going to supply the amplifier.
Yeah, I have, been trying to find, to have some things to test with, but I don't know if I'm even looking at the right sort of amplifiers.
Yeah, you
But
may want to find a different part.
I don't know. I'm not even familiar with that 83, with that.
8370.
Yeah.
Well, it seems pretty straightforward. I had no trouble programming. You just have to understand, how to do it, how to analyze the gain distribution.
That's the, yeah.
Which for a software guy with a double E degree, I have to, think about it. Way back at, I think it was Dayton, about 86 or so. I helped start a gasoline generator out in the flea market that had a clogged carburetor. And when I got it running, somebody said, "Hey, not bad for a software person." Come on, guys, I do have a double E degree. Jeez.
Software person.
But I don't think they ever taught
generators are analog.
They never taught us in double E school how to start a generator either. So
I was pretty motivated when my power went out the other day. Surprising what motivation will do.
Yeah. Learn how to clean a carburetor. Yeah.
Yeah, it's going to be about 10 o'clock here. I think I'm going to say 73 for the evening. But I can let you guys go. Keep going. Thank you very much, and happy holidays, everyone. Merry Christmas, Happy Hanukkah, Happy New Year, everything else.
Happy
Kwanzaa.
Are we canceling the next? Are we canceling the next 2 weeks?
Yes, I would think so, since next Monday is Christmas Day and the Monday after is New Year's Day. So I think we should cancel the next 2 weeks.
Okay.
That is not to say the Zoom link is always open, so you're always welcome to hop on whenever you want. But
this room is always open.
Yeah.
To get our fix.
Yeah. Yeah, you're welcome to come on whenever you want.
Does Zoom allow you to be in multiple rooms at once?
Yeah, I don't know.
On the Mac?
What it lets me do, I'm the host of this room, and what it lets me do is it lets me set up the standing meeting that anyone can join at any time. So I have a few of those set up.
Because this would be especially useful if I could be in multiple rooms at once, for different groups I'm in.
I don't know if they allow.
I don't think you can do that on the same computer, but there's nothing stopping you from doing it from multiple computers.
That's a kludge. Well, of course, in real life, I can't be in 2 rooms at once.
But people,
how can you be 2 places at once when you aren't
you're not
anywhere
anywhere
at all?
Right. That dates us all.
Yeah. So, I think this sounds very good, and I will. So thank you very much, and 73, everybody.
Okay.
73.
Do you want me to leave the recording on, or you want me to stop that?
Yeah. Stop it.
All right. So I'll stop that.
Yeah.